Hi everybody, this is Mark Weitzman. Welcome to my weekly blog. I missed last week's. As you can tell, I'm still recovering from a cold. I've had a pretty bad cold. I was exposed to somebody who had COVID, and I thought I might have it too. I've never had it, and I've been immunized with boosters like a zillion times. But I tested like 5 times already, and they're all negative. So it seems like I just had a pretty bad cold. Um, anyway, so that sort of impacted my physics for the week in terms of what I've been doing. Well, here's a little fooling around with the Chat GPT, which has taken the internet by storm, and it's pretty good if you want to send a friend who's suffering from a illness as well. You want to send them a poem and make them feel better, and so on. So that's one thing I've been doing. I've continued to read the Feynman papers on physics. I'm sort of working backwards. I've read the chapters on the parts on all those papers on computer theory, and about half on the quantum gravity, and now I went back to the physics of elementary particles. I've done the V minus A theory, which he and Gell-Mann worked on in the late 50s to explain weak interactions. And now I'm reading the about halfway through the stuff he did on partons and quarks and gluons. He's got some nice tutorials on gauge theories as well. So and I've continued to read. I finished the Schrodinger representation in Hatfield's book, Quantum Field Theory of Point Particles and Strings, and I'm going on to the path integrals, and I've gotten through the free particle path integral and the harmonic oscillator path integral. So Chapter 12 in Hatfield's book is a pretty decent review of path integrals, and it's something that I need to start making the videos in the version 2 in my quantum field theory course, and then we'll see. But like here, one of the things I plan to do today is to start working on, I got 2 more videos to do on functional calculus, the bosonic functional integrals and the fermionic functional integrals. But then I have to update all these, LSZ reduction, spin statistics, and all these videos that I made that weren't that good on path integrals and free field theory and interacting and so on. So I have to update all of that. That's on my agenda. And I've also been taking this course on, I've signed up for it, but I haven't been doing it. Luckily, it's one of those self-paced courses, computational data science and physics. And so I started it like last week. I got only a couple of weeks left. I got to do all the work. But I did 24% really fast. So far, I'm not that impressed with the course because a lot of it covers things that most people who are at this level sort of already know, things like probability distributions and so on. The stuff on error propagation using Python was okay. And then right now I'm doing the week 2 on data fitting, and the lessons are okay. And you're using real data like gravitational waves and cosmological constant and things like that, but it involves things like regression and things that I already know and machine learning. But I guess if you're not that familiar with that stuff, you can get a review here. The way they do statistics is like the most complicated way imaginable. The results are fairly easy, and I highly recommend the probability and statistics courses that are given at MIT in the computer engineering and computer science and electrical engineering department. They're much better treatment. And but just to show you what's involved with this course, it's mostly notebooks. They have all these notebooks. Excuse me. Which you can run locally. You can download all the stuff and run everything locally and set up in a virtual Python environment, or you can use their Google Colab, which is in the cloud. I prefer running locally. But, you just go through basically the lessons and the videos sort of overlap, and you just go through these notebooks one at a time. And, sometimes you have to fill in 1 or 2 lines of code. They do most of it for you, And, if you're into this stuff, I'm not that big a fan of notebooks and writing only a couple of lines of code. I like to do the whole program and everything, but they sort of do everything for you. It makes it easy to go through, and then they have a notebook on each thing, and it's sort of the lesson is in the notebook as well. As the videos don't really add that much. Quite honestly, I don't think the professor in this course is that great so far, but it is what it is. It's not like a Barton Zyback quantum mechanics course, but I'm sure it will get better and probably has its uses. And like I said, I've gone through all these notebooks, and basically you're gonna, and the problem sets aren't really that challenging. Again, and the people who always complain on MOOCs that they don't have enough attempts or something will love this course, because you get an infinite number of attempts for every question. So, you can't fail to get the right answer eventually. But this is the last notebook that I'm working on right now. So I've still got a ways to go, probably. This is one thing about MOOCs, they're time consuming, and you really wonder, it's like, I happen to have been sick, so I didn't mind taking some time off of my quantum field theory, which is, for me, it's tough to do when I'm sick, to concentrate that much and everything. And these I can sort of do, when I'm asleep. So that's all I have to say this week. I'll, again, as I mentioned, I'm going to try and add a couple of videos and finish lesson 5.5 over the next couple of days. And hopefully in the middle of this week, I'll get back into some serious physics. Thank you very much for watching. I'll see you next week.